Hey everyone, welcome to this ACM webinar. I'm excited to see so many of you interested in AI and machine learning and wanting to build careers. And what I want to do, and thank you also, Juan, for organizing this and helping to moderate this. I think the agenda, I think Juan is going to do some housekeeping and then I'll jump in and say some comments. But I think Juan?
Yeah, thanks, Andrew. Hi, and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. My name is Juan Miguel de Hoya. I'm an in-house consultant for artificial intelligence and emerging technologies at the United Nations, ITU, and a member of ACM and SIGGRAPH. I've also served as a contractor at Facebook, Oculus, and Google, worked at Pixar Animation Studios and Walt Disney Animation Studios. My current interests include artificial intelligence, computer vision, mixed reality, computational physics, the web, and kind of examining the human impact of computing in society. So you can find out more about my background in the bio widget on your screen. So for those of you who are unfamiliar with the ACM or what it has to offer, here's some more information available on the slide. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see more of those highlights on your screen. So before we get started, I'd like to quickly mention a few housekeeping items shown in the slide in front of you. If you're experiencing problems with the slides or audio, press the F5 key in Windows, Command +R if you're on a Mac, or refresh your browser on a mobile device. Or you can choose close and relaunch the presentation, which will hopefully reset everything. To control your volume, adjust the master volume on your computer. This webinar is driven by your questions, so please type them into the Q&A box at any time during the webinar and click the submit button. I'll be organizing and prioritizing your questions for Andrew. We'll try to get through as many questions as we can, and hopefully we'll be able to answer a lot of the overarching questions that are available. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. And check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it out to help us improve our webinars. You may also open the link to the survey at any time for the resources window on your screen. So in addition to these, you can use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag #ACMLearning. We'll be watching for your tweets. We also have a new community discourse page to continue the discussion after this webcast, including questions we won't be able to get through during the Q&A session. So today's presentation is Breaking into AI, a Q&A with Andrew Ng on building a career in machine learning by Dr. Andrew Ng. And so briefly, Dr. Andrew Ng is a general partner at the AI Fund, CEO of Landing AI, and Adjunct Professor at Stanford University. A globally recognized leader in AI, he was also the former chief scientist at Baidu, founding lead of Google Brain, co-founder of Coursera, and the founder of deeplearning.ai, educational AI education platform. So without further ado, Andrew, please take it away.
Oh, I'm sorry. I think I was muted. Let me just stop. Apologies. Welcome again, and thanks everyone for joining us today. I'm going to just talk for several minutes and then spend most of this meeting on hopefully taking your questions that Juan had kindly agreed to moderate. AI is the most exciting technical breakthrough of our time, maybe, and I think this creates a lot of opportunities for, I think, each of you to build a fantastic career and do very meaningful work in AI. And I've been fortunate to have led some of the great AI teams around the world and seen many people that were not previously working in AI break into AI and have do very important work, as well as have fantastic careers for themselves. And having led many of these teams, as well as seen, I guess, the careers over sometimes, over 10 years of many Stanford students, where I still continue to teach, I think I've learned to pattern match what are the things that maybe correlates with someone having a great career in AI. And so I prepared a few suggestions to share that with you. And a lot of these are things I've actually never talked about publicly before. But I think that in terms of building a career in AI, I think that first, I think it goes without saying that I hope you use these new superpowers to do important work that helps people and makes the world a better place. So let me just take that as a given. And then let me share some thoughts on what it takes to, for example, start a company or find a job that lets you do that type of work. And I'm going to try to draw on this tablet, so hopefully people can see this. It turns out that a lot of the most skilled individuals have a technical portfolio that looks like this, where if on the horizontal axis, I plot the area, and on the vertical axis, we plot your depth of knowledge. Well, this pen is really thick. Let me reduce thickness. A lot of the most skilled individuals in AI have a portfolio that looks like this, where you would know something about machine learning, know something about neural nets, know something maybe about other things as well, about graphical models, about data science, know how to write code, and so on. And but that a lot of the most highly sought after candidates, I guess, also have a very strong vertical in at least one area, and maybe a couple of other, and maybe a couple areas. You might heard of a T-shaped individual, and a lot of the most skilled individuals in AI both have the breadth of knowledge as well as the significant depth in one area. And I find that to learn that horizontal piece, coursework plus reading research papers turns out to be a very efficient way for you to learn that type of knowledge. When I teach on Coursera, one of the philosophies I have is to try to make sure that if you spend 5 minutes in one of the courses that I teach, I want that to be the most efficient possible use of your 5 minutes to learn something. But I think more generally, coursework at all the great universities, as well as on MOOCs, are a very efficient way for you to pick up that breadth of knowledge. And then, fortunately or unfortunately, the state of the art in AI and machine learning today, a lot of that knowledge has not yet been organized into coursework. So if you want to apply AI for earthquake prediction, or AI for improving logistics, or AI for a lot of problems in healthcare, or cutting-edge AI algorithms, a lot of that knowledge has not yet been organized into any courses. And so while a highly organized course is an efficient way for you to do that, to learn these things, I think that for you to figure out the cutting edge of AI today, there is no better source of knowledge, unfortunately, than trying to read some research papers as well, especially in the vertical area that you're interested in. And then the other part that really most people's career is that vertical, where you might pick a vertical, say deep learning or neural networks, and build projects in deep learning, or go really or spend a lot of time to work on an open source project. And a project could be a project that you do in your company. For those of you that are still in school, doing an internship can help a lot, or doing a research project in a university. But it's often that practical depth of knowledge that allows you to demonstrate the skills. I find that in today's world, recruiters are very good at valuing or understanding what you can actually do. And so I think the strongest correlate to your, say, finding a great job at a great company is more what you can actually do, even more than the stamp of approval that happen to be on your resume. And I think that for you to be good at AI, you do need the technical skills, and I think the coursework and reading papers is a good way to pick up the technical skills, but then also to know how to actually build systems, how to actually make machine learning systems work. And I think even though we do our best, on the Coursera Deep Learning Specialization, Coursera Machine Learning course, to teach people how to do that, there is an additional layer of knowledge that is useful, hands-on knowledge that's useful to gain through working on concrete projects. So if we look at the breadth of knowledge as well as the depth, then this is really corresponds as well to what a lot of interviewing processes look like, where recruiter will ask, for example, machine learning quizzes, and it's really taking the online coursework will help you answer the machine learning quizzes, but then also being able to demonstrate a portfolio of work will help. Will help make sure that you have the right skill to know how to do these projects. And then I want to mention just two more things, and then we'll go to questions. And one is the importance of dirty work. I feel like when I talk to some of my friends outside AI, they think that the way we work in AI is that we're in these brightly lit rooms with a Zen garden outside the window, interspersed with yoga sessions, and we stand in front of a whiteboard, like this whiteboard maybe, to philosophize about the future of humanity, right? But when I look at the work that I do in AI, frankly, a lot of this dirty work is downloading that data set, cleaning the data set, plotting a learning curve and trying to figure out what's wrong. The meeting that I just came out of, literally, I guess 15 minutes ago, I was with one of the teams at Landing AI. We're looking at a lot of plots of PCA, right? And trying to figure out why is PCA giving this result. We project a low-dimensional subspace. Why is this data in disorder? So most of the most meaningful projects in life, dirty. And I think that is often when you have this massive pile of little pieces of dirty work everyone does, that this massive pile of dirty work turns into something really glorious and can help a lot of people. So I would say, and I think that the media has presented AI in such a glamorous way that I'm seeing a little bit of FOMO, or fear of missing out, if individuals feel like they're not in that brilliant, natural sunlight room with, and where's my Zen garden? I don't have a Zen garden feeling. So I would say, don't be afraid of jumping into doing dirty work. And I think the second thing is, lifelong learning, right? Even today, actually, let me go off camera for a second to grab something to show you. So I feel like I'm speaking to you from my office. But even today, I still read research papers regularly. So this is a folder that I keep in my backpack, and I kind of have a set of research papers, right, that I keep around. And so I find that, they can't see the video. And so, actually, I'm not sure you can see my video, but I find that even today, actually, for example, this is one paper that I've not yet read, but is printed out. But I find that even today, as a CEO of a company, for me to keep my skills sharp, I still try to read a few research papers every week. And the secret to becoming good at machine learning is not spending one weekend studying really, really hard. It's about setting up your life so that every week you could do, a little bit, so that every week you could study a little bit. Study a little bit in an online course, or when you're done with the online courses, study a little bit in the sense of finding some research papers and reading them so that you could, because it turns out if you read 2 papers a week, then after a year, you'll have read 100 papers. And that's a huge amount of knowledge that you will have ingested. Whereas if you read 2 papers a week, for one weekend, then that doesn't actually move the needle that much. So I carry this folder in my backpack, to a lot of places I'm going, so that if I'm in a Lyft or Uber and don't have something else to do, that I'll try to read a few papers a week. And I hope that many of you will become that type of lifelong learner that can help you keep on getting better at AI skills, because I think the job market today, as well as your opportunity to start your own thing, do something really impactful, is actually very correlated with the actual skill that you have, and not as correlated as it used to be with the stamps of approval that you happen to have on your resume. So I think, let's see, I'm excited. One last thing, then we'll go to questions. I think that one last insight. I think that the best untapped opportunities in AI, the biggest untapped opportunities in AI lie outside the software industry. There's a lot of exciting work to be done in the software industry still for AI. I'm very proud of the teams I built or helped build at Google and Baidu, and and used to lead the Stanford AI lab and so on. Those are great teams. There's important work to be done in the software industry. But if you look outside the software industry, in sectors ranging from agriculture to manufacturing to logistics and retail, there are a lot of people that could really use machine learning tools, but have a very hard time figuring it out without the help of people like us from the ACM community. So as you build your careers, I would encourage you to look into software industry, certainly, but also look outside the software industry. If you look at the McKinsey reports, for example, then certainly on a global GDP growth basis, a lot of the biggest opportunities, I would say the much larger percentage of the opportunities in AI lie in more traditional sectors than the tech industry. So let me just wrap up my initial introductory comments, and then I think many of you had sent in questions, and Juan was going to select questions and have me answer some of them.
Yeah, absolutely. I'm going through the questions right now. It's like drinking from a fire hose is what I'd say. But yeah, I think it was really fascinating, I think, from hearing your perspective of lifelong learning, because I actually do have a binder of research papers myself. And although I'm in the middle of transitioning roles from kind of computational physics and doing a lot of graphics more into the AI space, I still keep those binders of research papers that I had kind of learned from the start. So kind of like some of the higher level questions I'm seeing so far has been mostly about, first, how does one really navigate between becoming a computing professional? And one question that's being brought up is kind of how does one plan, as a student, how does one plan to develop their career while they're in academia? There's a couple of routes where you can go immediately into industry immediately after graduating from undergrad, or you can pursue kind of like either your master's or a PhD in machine learning. And so I was kind of wondering, Andrew, what your perspective is on the efficacy or the value of being able to pursue a graduate degree, or kind of what avenues you can have to develop that career.
Yeah, so I think that, let's see, I think today, getting to a top MS program or a top PhD program, or finding a job with a top machine learning or AI team, I think all of these are great options. The world is shifting to a mode where a master's or a PhD on your resume is helpful, but it's not necessary in most companies to operate at the highest levels of technical leadership to have a master's or a PhD. So what I would recommend most people do is consider all of these things at the same time, meaning go ahead and apply to graduate programs, and also look at what opportunities you have in a company. And then based on the graduate programs you're admitted to, as well as the opportunities you have or think you have in companies or starting your own company, pick the thing that matters the most. I find that one of the strongest predictors of your success will be who are the people around you. And so I think there have been results in sociology. Some of these results are slightly controversial, but I'll quote them anyway. There have been some results in sociology that suggest that if your 5 closest friends are overweight, then you are more likely to be overweight. If your 5 closest friends are smokers, you're actually more likely to be smokers. I don't think there's a result in sociology that shows that if your 5 closest friends are, are really hardworking, reading a lot of papers, doing great work on machine learning, then you were more likely to be doing great work on machine learning. I don't think that study's been done, but I'd be very surprised if it turns out not to be true. So when you're selecting an opportunity, be it a master's or a PhD or a job, I recommend that you focus on the, let's call it the 10 to 30 persons you interact with most closely. Because I think that it is those individuals, as well as your manager or advisor, that will have the biggest impact on your experience. One thing I would recommend you not do is overly focus on the brand of the company or the brand of the university you're joining, because I think the variability within a company is actually very large. And so what happens, I think in today's world, there are some companies that are very, very large with, I don't know, I'm just gonna make up a number. And I'm not thinking of any one specific company, but there are multiple companies that fit this portfolio. There's some very large companies with, say, anywhere from 10,000 to 100,000 employees, I'll just say with 50,000 employees, and they may have a small team, of say 300 people that does great work in AI, and you might hear about this great work of 100 or 200 or 300 or 500 people. And I think that if you get a job offer to join that specific group, and if you in fact know who are the 10 to 30 people you interact with most, then that could be a great job offer. But you get a job offer that says, oh, we're a great company, join us. We'll have some rotation program, we'll have some matching program, and then maybe we'll put you in some AI group. Then I personally find those job offers much less compelling. So I actually drew this picture to a group of Stanford students about a year ago in the Stanford deep learning class, and actually, right. So actually, many years ago, I saw a Stanford student. There was a great Stanford student doing great work at Stanford, and he joined a very large company because it was, supposedly a very good AI company. And somewhat sadly, this particular Stanford student, whose career was really rising, he wound up being assigned to a Java backend payment processing team. And for those of you that work on Java backend payment processing, no disrespect intended, I think Java backend payment processing systems are great. But this was Stanford student's career kind of plateaued for about a year and a half, and he was actually very unhappy until after that year and a half, he actually left this particular big company. And I think, and then an interesting part of the story, I told this exact same story to Stanford University's deep learning class, which I teach at Stanford, and there was some remote students taking the Stanford class via remote video. And so one of the Stanford students who works in the company, he emailed me shortly right after that class and said, hey, Andrew, I wish you had told me this 2 years ago, because this is the exact thing that happened to me. And it's actually from the same company. So I think that knowing what's the exact team you will work with is very important, rather than just joining a company with a great brand in the hope that maybe they will send you to an interesting team to work with.
No, that's a really good point. I think what's really fascinating is, because I was reading Kai-Fu Lee's recent book, AI Superpowers, is how he discusses how I think in this current age we're moving away from something like the age of discovery, where we're trying to figure out like new advances and breakthroughs necessarily, towards implementation. And so the argument there that he made was that it's not necessarily valuable to be an extremely strong pioneer, so much as you have the ability to utilize artificial intelligence for implementation. And so I think that kind of leads to kind of a question that I've had, and I think has been brought up in some of these questions, is like, is it necessarily valuable to be strong or deep in one particular domain, such as artificial intelligence, purely as an artificial intelligence engineer or machine learning engineer, or does one benefit from being more of a jack of all trades, where you are becoming more cross-disciplinary?
I think that, let's see, a lot of the best work to be done in AI will be cross-disciplinary work, but I don't think every individual has to be a cross-disciplinary individual. So actually, for example, last night, I guess, actually, literally last night, about 14 hours ago, I was at Stanford going over some of the projects that my Stanford AI PhD students have been doing in collaboration with the Stanford School of Medicine. And so I think it's very difficult for my PhD students at Stanford, which are primarily computer scientists, to become very, very deep experts in healthcare. But by working with doctors from the School of Medicine, we had radiologists in the room, we had pathologists in the room, we had people working on healthcare statistics. We're able to form the interdisciplinary teams that can look at where AI can create value in healthcare. Another example, I'm actually speaking to you from the Landing AI office. One of the projects that Landing is working on is an AI applied to agriculture. So, I think my grandfather was raised on a rice paddy. My grandfather recently turned 100 years old. And when he was young, he was actually raised on a rice paddy. So this is the rice paddy he was raised on, but I don't have that deep knowledge of agriculture. But we work with experts in agricultural machinery, and I think it's often having those interdisciplinary teams that lets us work together to figure out the most valuable projects to work on. And by the way, I feel like the work we get to do in AI is really fun. So a few months ago, I got to drive a tractor, right? Because we're working on AI applied to agriculture, and it turns out that if you drive a normal car, the steering wheel, you could see which way is north on the steering wheel. The steering wheel is straight, then the car goes straight. But the tractor, at least the one that I was driving, the steering wheel to go straight, the steering wheel was turned at some weird angle, and so you just got used to that. To go straight, steering was turned at some weird angle, and then to try to turn right, I would turn the steering wheel clockwise, a giant steering wheel. But I find a lot of this work in AI really fun. I mean, in what other discipline in computer science would you get to drive a tractor, right? It's a huge tractor. It's a very, very, very tall, giant tractor. And as an AI scientist and AI engineer, this is the work I get to do. So it's just, what could be more fun than working in AI where you get to really drive a tractor?
No, yeah, absolutely. I think that's kind of one of the joys of being able to do, to not necessarily to be able to couple the work and kind of see it from the perspective of different disciplines. I'm definitely experiencing that myself in my work. So let's try, with that in mind, kind of like Andrew, one of the questions I think that's coming up too is how long someone can get into AI. I think there's or like how long does it take to build sufficient and meaningful depth in one of the AI areas. I think this is a kind of a question relevant for both like people who are emerging practitioners interested in kind of being in the field, as well as people who are interested in transitioning, and just kind of get a sense of how much of an investment they can make in their self-education so that it will be meaningful for them to tackle the domain.
I think we now live in a world where you don't necessarily need to go and spend 2 years to become expert at something and then to start to apply it. I think we increasingly live in a world where you could learn a bit and then start to apply it a bit and then keep learning and then become even better at applying it even more. And then that is a lifelong process of lifelong learning and continuing to get better and better. So I've been very inspired by the number of people that took my machine learning course on Coursera, or that are taking the deep learning specialization on Coursera, and that through just one course or a very small number of online courses is already able to apply these things in a very meaningful way. I feel like, I don't know, recently I saw a blog post from a student that had taken a machine learning course and was using it to build a coffee machine to fine-tune the way he was roasting his coffee beans, right? And it turns out I actually drink a lot of coffee. My wife sometimes has coffee beans at home. So I was like, wow, I guess I didn't want to suggest to Carol that she needs my wife to build a learning algorithm to do a better job roasting our coffee beans. But I was like, wow, rather than us roasting our my wife Carol used to roast coffee beans on a little popcorn maker. It's a very cheap thing, and sometimes we burn our coffee beans. But it's like this guy had figured out how to use machine learning algorithms to optimize roasting of coffee beans, and maybe it'll be a business. I don't know, but I think that with just a little bit of learning, if you look at your company and the projects you're excited in, I think you should try to excuse me. You should try to apply it to whatever problem you can. And then I think it is a lifelong learning process. And so I think, the Coursera machine learning course is 10 weeks. I think after that, or the Coursera deep learning specialization is a few months. And I think after, let's call it 10 to 15 weeks, you should have enough of the basic skills to be able to start applying this. And then maybe some guidelines. If you're trying to break into a new area, I feel like if you read and reasonably deeply understand 10 to 20 research papers, you have a good basic understanding of the area. So it's not that much, right? 10 papers, maybe 20 papers. If you read 50 papers, you become pretty knowledgeable. And if you read 100 papers, then you might know enough about an area to start to have research ideas to even start pushing the state of the art. So those are some numbers. 100 papers is a lot, but if you read 2 papers a week, that's just 1 year. And after reading 100 research papers, you actually become knowledgeable enough. I feel like for PhD students at Stanford, I feel like, by the time they read 100 research papers, usually the human brain is a magical thing. I don't know how the human brain works, but whenever I'm looking for new ideas, I read a lot, take online courses, I read a lot, either papers or books. And then for a lot of people, it seems that whenever you read that much, magically you start to have your own new novel ideas. But I think, and I hope this paper count is a very crude metric, but maybe it gives people a rough sense. And one of my friends at a different university was trying to teach a new class on a specialized area of machine learning, and he was planning to read 200 papers to become really, really expert, and then to try to teach a class at this other university. So I hope those counts give a rough sense.
Right. That's really funny. I think my dad, when he sees me read research papers, calls me, well, if I had a penny for every paper you've read, you'll be a very learned man, very rich and learned man. So, I kind of get it. I think, actually, I'm going to switch to a question here that's kind of popping up that's really interesting. So as a big question, I think, and I've had this discussion with a few folks, is it seems like kind of the basics of machine learning have gone kind of from being experimental to commoditized, and that there are a lot of these established platforms where anyone can learn in a few weeks. And I think the question that a lot of people ask, and I think this, and I'm going to pivot the question in a bit too, is is there any areas and techniques that you think are going to be valuable or exciting for you, for developers in 5 years from now, that people should foresee and kind of be interested in from your perspective?
Let me mention a few things that I think are exciting. I think over the last few years, machine learning, especially big tech companies, right, which has very large marketing departments and therefore has a certain influence on PR. I think a lot of the early progress in deep learning was made by training giant neural networks on very large data sets. So, you build a machine translation system, train on a gazillion pairs of sentences in parallel corpora, and build a giant neural network that works really well. Or speech recognition, train a giant neural network on, many tens of thousands of hours of data. So a lot of the breakthroughs, first wave of breakthroughs in deep learning was really giant neural networks trained on big data. I think one of the underappreciated areas is how to apply learning algorithms even on small data. So I run into a lot of problems where there are only, say medical imaging, there might be only 100 X-ray images or 100 pathology images that you can get from a doctor, and that's all the data set there is. And I find that if you have 1 million images, like ImageNet, today there are many dozens of teams around the world, maybe hundreds of teams that can build a pretty good image classifier if you have 1 million images. But if you have only 100 images, then the skill of the machine learning team matters much more. And I think our tools and workflows and processes are not that mature. So I think that's one important area for research. Another important area is, I think, generalizability. So here's what I mean. Today, we can publish papers like that. Given enough data, we can train an X-ray diagnosis system that maybe outperforms a human radiologist, right? So there are papers with, that flavor being published by my group and by other groups. But one weakness of learning algorithms today compared to any human radiologist is the ability to generalize to if the X-ray machine was a little bit older and a little bit speckled or a little bit lower resolution, or if you train on lots of data from, say, Stanford Hospital, where Stanford has relatively high-end X-ray machines, very professional technicians, but if you take that model and you try to generalize it to a different hospital where maybe the X-ray technician, consistently has the people tilted a little bit to the side for some reason, a human radiologist generalizes to new distributions of data much better than today's learning algorithms do. So I think generalizability is another set of tools that my applied teams, I guess, are constantly running into. And then I think maybe finally, I feel like in the software engineering world, it took us a long time to invent things like Scrum and Agile and the concept of code reviews, right? That was a great idea, right? Code reviews. I think in the machine learning world, we're still in the early phases of figuring out what are the processes to enable a team to work together on a machine learning project. So, and one concrete example, if you look at the role of a product manager, the products we build in machine learning tend to have a statistical acceptance criteria, right? So it's not that, the self-driving car is either right or wrong, it's that you need a component that detects all pedestrians, within a certain distance from the car at this many nines of reliability. And so our PRDs, our product requirement documents, are moving to specify product definitions in a statistical way. And so my teams are recreating or training up new product managers that can write this very different format of a PRD, of a product requirement document, where it's not about drawing a wireframe, but it's about providing a data set and an evaluation metric and a target specification. So I think how we work as engineers to build meaningful machine learning projects, I think all of us are still in the early phases of figuring that out.
No, that totally makes sense. Actually, I wanted to go back on something that was particularly interesting. There's a question here by that kind of asks what kind of roles I think you, Dr. Nung, can envision a lot of engineers play as we kind of go towards converging into a society where AI is kind of integrated, and whether as an engineer who, as an engineer or someone who's interested in AI, is programming necessary to be part of that space?
Oh, yeah. So I think that programming is important, especially for engineers. Let's see. So it is possible in some companies today to get a job as a machine learning engineer if mainly you know how to build machine learning models. It's possible to get a job as a data scientist in some companies or a machine learning engineer. Right. But, once upon a time, most of society was illiterate, right? Most people did not know how to read or write. And the perspective of society was, look, you don't need to learn to read or write. All you need to do is go to the religious institutions, and then the monk can read the sacred text to you, and you don't need to read it yourself because, the monk or the religious leader can do all the reading you need, right? And then I think later we started to have a few, and then it was later, so no, well, does everyone need to read? Maybe you just need a few people writing the most important text. But what we learned as a society was that when almost everyone knows how to read or write, then it really makes person-to-person communication much more efficient. So it's not just about, a few authors that know how to writing all the hits. Today, two friends can send each other an email. You can now write for an audience of one. So I think that the technical world, the technology world is still kind of in that earlier phase where there's so few people that know how to code that most of the people that do know how to code have to focus on doing work that affects a huge number of people. But I think, just as literacy is a fundamental building block of human-to-human communications, I think that for the foreseeable future, coding will be the deepest and most fundamental building block for human and machine communications. And since human-machine communications seems like it is a important and even growing piece of importance of our society, I would love to see a future where, just like today, we think every child, pretty much should learn to read and write. I think in the future, every child deserves to learn how to communicate with computers at the deepest levels as well. And what that means is that if we can get this future, then it won't be just a relatively small fraction of software engineers that can code and they write the code for everyone. Instead, it'll be that maybe at a mom and pop store, like a corner grocery store, maybe that mom and pop store can write a piece of software to create an LCD display for the front window that helps highlight their weekly promotions for that, corner grocery store. And I think because of the growing importance of human-machine communication, I think the whole world would be better off if everyone knows how to code.
Yeah, no, that's a very good point. I think for me personally, I think a big part of like a lot of my upward mobility as a young professional has been all about being able to learn to code and understanding kind of the mechanics and philosophy behind it, being able to apply it into kind of like whatever I do. I think it goes to kind of one of the tenets that ACM has, where we are trying to examine the human impact of technology in a positive manner to society as professionals, that we're enabled to do that. One question I think that came up here on the feed was, since we're talking about artificial intelligence and kind of integration and human-computer communication, is whether there's currently a good way to find AI job opportunities outside of just the software industry, and specifically working with big technology companies. I think a lot of people currently are very interested in examining kind of that impact, but maybe there's some gap in terms of like kind of bridging that skill set with non-perceived traditional like roles, software engineering roles. So.
Yeah, yes, it's a great question. I don't have a very constructive suggestion other than the obvious, search in the web search engines and the online job sites and so on. I think one of the challenges, but again, hoping we, all of us, ACM, us as a community, can hope to work to this, is a lack of CEOs or managers that know how to build AI projects within their organizations. So actually, I actually tell you, when I at Landing AI, I end up chatting with CEOs on a reasonably frequently. The top questions I get, so a lot of CEOs, a lot of traditional companies are excited about AI, but the top questions I get from CEOs are, number one is how do I build an AI team, right? If I'm not one of the hot tech companies, how do I recruit AI talent? And then number two is how do I decide what projects to work on, what projects not to work on? So it's very difficult today for even CEOs to figure out what is technically feasible as well as valuable, which is why, for example, this happened to me multiple times where I would hear a large, for example, a large car maker, CEO stand on stage and announce a very aggressive roadmap for building self-driving cars. And then literally 20 minutes later, I would speak with one of the engineers, there's also at the event, and the engineer would say, no, we're not doing what the CEO says. Everyone knows what the CEO just said is impossible, and we're just not doing that. And I think that it's actually very difficult for CEOs today. Many CEOs are still trying to form the judgment about what projects to work on and what projects not to work on. And then I think number three is AI strategy. Many CEOs are trying to figure out, given that you work in agriculture or manufacturing or healthcare or logistics or some other company, how do you align your company strategy with AI strategy? One of the things I'm hoping to do, I've been working on creating a new AI for Everyone course, which is a course on AI addressing a non-technical audience. So if you're a CEO manager, a product manager, a marketer, or recruiter that does not have a technical background, what are the things you should learn about AI in order to help your company navigate the rise of AI? And so I hope that a course like AI for Everyone, which will appear in Coursera early next year, can help many more companies figure out how to use AI and help them be more effective at putting online the job descriptions and bringing in in-house AI talent, which will create more job opportunities for everyone as well.
Right. No, that's a fair point. Going back a little bit, I think some people have kind of mentioned there's a lot going on in the space in terms of like information and coursework and resources. And a big concern has been kind of like how to figure out which ones are particularly valuable and which ones aren't. And I think I was curious about, as your perspective as a professor and someone who is interested in lifelong learning, how do you develop a habit for figuring out which of the content or resources that you're looking at is of value to you as an engineer?
Yeah.
In artificial intelligence. Yeah.
Yeah, so I think for people wanting to learn about AI and machine learning, I think the first set of learnings probably should come from coursework. I think, almost all the facts about AI that I know are on the internet, right? Somewhere there's a paper like on archive on the internet describing almost all the publicly known, public domain facts about AI. But there's so much knowledge out there that I think that coursework is actually a very efficient way to pick up that knowledge. Now, beyond a certain point, you will exhaust the coursework that is available. Right? There are only so many Coursera courses on AI. And then beyond that, I find that if you're jumping from scattered source to scattered source, it's very difficult to be time efficient in how you learn these things. And so what I actually end up doing is, and this is what I recommend to my teams as well, is first do the coursework. And then after that, if you want to learn an area, usually through internet searches or finding blog posts or finding lists of papers, let's say you want to become very knowledgeable about machine learning applied to chatbots, right? Or machine learning applied to radiology, or machine learning applied to earthquake prediction. What I usually do is do internet searches to curate a list of papers for myself or for the team to read. And I think, actually, let me just describe what this process feels like. So let me share the screen again. Okay, great. So I think, and so I think that, let's see. So what I might do is do internet searches and start off with finding a list of 5 initial papers in a vertical area that I'm trying to learn about. And this is what it feels like to read these papers. If on the horizontal axis, this is 0% complete, going up to, say, this is 100% complete. What I would usually do is skim all 5 papers, so we spend 10% of the effort needed to 100% understand each paper. And what usually happens is after doing this, you realize that, paper 2 has an incorrect approach and so stop wasting time on that. But paper 3 is really important. Then spend all the time needed to go and deeply understand that until you're at 100% understanding. And based on that, you find papers 6 and 7 based on additional web searches or citations, and then skim those. And based on those, you might decide that paper 4 is worth a lot of effort to deeply understand. And then paper 6, you might try to understand the whole thing in full. But this is, I'm trying to describe you the feeling, I guess, of what it's like to curate a list of papers and then kind of skip around. And then eventually you might end up with, let's say, 20 papers, and eventually just in a more systematic way, through some process of reading, skimming, where some of them you decide to not waste time on, but then find a list of anywhere from 10 to 20 to, on the high end, would be 100 papers, and just allocate the time to systematically go through them. And I find that if you're interested in one specific vertical area, such as AI applied to something, or even new technical area, like you want to learn more about GANs, or learn more about VAEs, or learn more about model compression for deployment at the edge with a small memory footprint. This is a good, maybe formula, a good recipe for curating a reading list and then going through it. And this takes time. So one of the things that we do, that I do, is participate in reading groups with my friends. And so I find that also helps us, helps us learn from each other.
No, that totally makes sense. Let's see. Now, there's a quick question here. I think a lot of people as engineers are finding kind of difficulty, I guess, explaining to upper management about the value or benefits of artificial intelligence. I think there is definitely a kind of a perspective in terms of like the perspective and narrative for artificial intelligence has been propagated that sometimes is negative, right? We have like sci-fi fiction regarding like artificial intelligence. And I was kind of wondering whether you had any advice or perspectives on how to explain those benefits or of introducing AI and any workflow for to management. So.
Yeah, I hope that when the AI for Everyone course comes out, that you'll be able to go to your upper management and say, hey, could you please take this AI for Everyone course on Coursera, and that will help give the executives several hours of education about what is supervised learning, what is data, how do you think about data, what's the workflow of a machine learning project, what is really hype and what is the real stuff. So how do you think about AGI versus ANI, artificial narrow intelligence? I think right now a lot of that content exists in scattered forms on the internet. So you find, one or two HBR articles or other types of things. You could try folding things like that from well-known, trusted authorities to manage to some of the executives and hope that they'll influence them. But I'm hoping to compile the most useful set of knowledge into the new AI for Everyone course, which will be coming out early next year.
Right. No, that totally makes sense. I think it's a question of kind of like literacy, I think, or creating educational literacy for AI and machine learning skills, because we are transitioning into a space where that's going to be pervasive. To that end, I was just kind of curious. So we're going to be the expectation, I think, is that we're going to be transitioning into the state where a lot of the jobs will potentially be changed a little bit, like even engineering jobs will be changed a little bit. And I guess the question would be, as lifelong learners, how do we prepare for that transition without, like, for example, I'm not as familiar with like how to prepare for it, and how do we prepare and educate, like, potentially, our children as well to have these skills and access to opportunities?
Yeah, I think for those who have children, one of the best things you could do for your children will be to cultivate in them the skill of lifelong learning. And I do think you should teach your kids to code, not at age 1, but when they're a little bit older, right? And when they're old enough to actually learn to code. I do think, just as we once wanted to make all the society literate, today we all teach your kids to read and write. I think you should teach your kids to code as well. But I think teaching them the skill of and the importance of becoming a lifelong learner would be one of the best things you could do for your children. So I think those are things we should do at the individual level. And at the societal level, Silicon Valley has a lot of hype about unconditional basic income, which is the idea that you pay people with no strings attached. And I don't know, I've heard some uncharitable descriptions of unconditional basic income as, well, let's pay people without a job so that, right, they'll stop bothering us. And I think that there's a very uncharitable description that's maybe a bit unfair, but I don't think unconditional basic income is a good idea. But I think because I think there's a lot of dignity to work, and so I would love to see governments around the world, including hopefully the U.S. government, but really governments around the world, put in place a conditional basic income, which is a variation of basic income, but that does have strings attached. And the string can be that if you're unemployed, we'll give you a social safety net, make sure you can live and be healthy and have, take care of your family. But the string that could be attached is that you have to do something, such as study, to increase the odds of this individual gaining the skills you need to re-enter the workforce and contribute back to the tax base that is contributing to all of this. In today's world, there are a lot of jobs for which we can't find enough people to do the work. Right? In the United States, we can't find enough healthcare workers. We don't. For some reason, we don't have enough wind turbine technicians. So there are a lot of jobs for which we don't have enough people to do the work. And the solution is not to get everyone to be a software engineer. I don't think that will work either. But there are a lot of other jobs, like wind turbine technician, that if factory automation affects some individuals' jobs, that they can take their skills to move laterally. And if we provide the training or give them the support structure to get the training to take on these related jobs, then I think that will help the individual because they can feel they can be active contributing members of society rather than living off an unconditional basic income. So I think it would be better for them and the families in the community. So I would love to see governments, experiment and roll out programs like that.
No, absolutely. I think that's kind of the big reason why I'm pursuing the United Nations myself, is just to kind of understand kind of the role, that role. Give me a quick second. Yeah. Sorry about that. I think I got a phone call. Yeah, so we have a few more minutes left, and I think I'm going to ask a quick question that has been also coming up, but I think hopefully it will be a fun one. Are there any books or research papers that you particularly got you started or excited about when you were starting out? And actually, on a higher level, what made you very interested in this field, in this space?
Yeah, so I think, I wonder if I'm able to share this. No, I don't think I have it on this computer. So just this past weekend, I was, actually, maybe I could, let me see if I can pull this out. So I found this just this past Saturday. Let me see if I could share this. But just this past Saturday, I found a paper that my father had published in 1980. Wow. I was 4 years old. And my father had published this paper in applying machine learning algorithms to do a medical diagnosis way back in, I guess, 1980. And I think, one of the reasons I even got interested in AI in the first place was because when I was in my teens, my father was a doctor practicing in Singapore, was working on machine learning applied to healthcare. And I think in hindsight, the algorithms, the whole world was using, that my father was using way back, were just not that effective. But it was, I was fortunate that I was a teenager. I learned about the rudimentary aspects of machine learning from my father. And then maybe it shows a lack of imagination, because I've been doing machine learning ever since then. And I think, yeah, and actually one fascinating part to me was even back then, my father was writing about things that we still talk about today, such as should these algorithms, which is that maybe we do not want these algorithms to replace human doctors, but that actually, let me see if I can share this. So it's literally just this weekend that I pulled up the conference proceedings. My father had sent me the hard copy of the conference proceedings, and so I scanned in the paper. Let's see. All right, yeah, you can see R.P. Ronald is my father. And actually, if you go to this page, not sure people can read this paragraph, but not sure people can see my mouse, but it says, computers not meant to replace a physician, but it's more correct interpretation of lab data. It could help sharpen a physician's clinical judgment. And so I think it's fascinating that with much better technology, much better learning algorithms, maybe we could bring this vision that, people get this done with much better technology.
No, that's fantastic. Yeah, I think, sorry.
Oh, yeah. So, yeah. So I think, so maybe if there was one paper that would credit with helping me get started in machine learning, it was the fact that my father was writing research papers like this. And so got excited about, machine learning when I was a teenager, and taught me how to code, and then come and say, hey, Andrew, check out this, expert system, or check out this, now we know, some horribly dated machine learning algorithm. So, and for those of you too with children, think about the work you are doing today, and if you can get your child excited and go to them and say, hey, check out this cool neural network you are building, maybe that will have an impact on some of your children's lives as well, for those of you with kids.
No, that sounds fantastic. And I was going to say, I don't think you were lacking imagination when you took this role. I think you've influenced a lot of people to have that impact and to embody kind of artificial intelligence as part of their careers. So actually, we're about running out of time, but I'd like to thank Andrew. Thank you so much for kind of your perspective and take on how to build a career in artificial intelligence and machine learning. It's been kind of an honor to be able to get those insights from you. And this webinar was recorded, and just wanted to tell everyone that this webinar was recorded and will be available online in a few days at webinar.acm.org. You can find announcements on upcoming webinars and other ACM activities at learning.acm.org and acm.org. Also, please fill out our quick survey where you can suggest future topics or speakers, which you should see on your screen right now. So on behalf of the ACM, Dr. Andrew Ng and myself, Juan Miguel de Hoya, I'd like to say thanks again for joining us. And I hope that you will continue to join us in the future as well. That concludes our webinar.